Okay, so for Math 3, Unit 8, Objective 6, we're going to take a look at our radians and trig functions. And so our last objective was our intro into radians. And so we're just going to kind of expand on that. So one of the pieces that we're going to be working with is, when do we have a 60-degree angle? What is that equivalent to? And that would be pi over 3. When is 45 degrees equivalent in radians? And that would be at pi over 4. And 30 degrees would be equivalent at pi over 6. So one of the pieces that will help us, remember that piece is that we know one full rotation in a circle is 360 degrees. And that would be the same as 2 pi radians. And then at the same time, we know 180 degrees is half of a rotation, and so would be 1 pi radian. So when we go halfway around a circle, that's 180 in degrees, or in radians, that would be 1 pi radian. So if we keep in mind that 180 and pi are the same, when we look at this pi over 6, what we need to remember is pi is the same as 180 degrees. And how many times does 6 go into 180? It goes in 30 degrees time. And that's why it's equal to 30 degrees. And then if we take a look at this pi over 3, same idea. Pi, what is pi the same as? 180 degrees. So what's 180? Because remember, pi is 180 divided by 3, and it is 60 degrees. And that's where we get those values from. And the same thing here, if we think of, pi as being 180 degrees, 180 divided by 4 is 45 degrees. So we're going to have to make sure that we know each of these because we will be using them regularly. All right, so we have our unit triangle. So remember, we have a unit triangle whenever the hypotenuse is equal to 1. And so that's what's happening here. And so if we haven't already, we need to make sure that we are learning these values very well. So we know that 30 degrees is the smallest angle, and across from it is the smallest side. And that shorter distance is 1/2, right? So 1/2 is a smaller value, and that is on the shortest leg. And then across from the 60 degrees is the longer leg, and so root 3 over 2 would be longer. And that's because the square root of 3 is bigger than the square root of 1, and so that's why we have that. And then when we look at our other special right triangle of 45, 45, 90, we know that it's isosceles, meaning that the legs are exactly the same measurement because the angles are the same measurement. And so that value is 1 over the square root of 2, or we can rationalize the denominator, and then it would be equal to the square root of 2 over 2. All right, so really important for us to know those. All right, so let's go ahead and take a look at how we do a few of these problems here. So the first thing we want to do is sketch the angle in standard position. So we have a denominator here of 6, so we're going to go in a positive direction, so that would be 0. This would normally be 1 pi, but we want to match up that denominator, so that'll make that 6 over 6. And then we'll take that and double it. That gives us the 12 pi over 6, or 2 pi, right? Because that's equal. And then take half of 6 because we want to go halfway around. So that would be 3 pi over 6. And then just count by 3 pi's to finish out. So we know this rotation here would be 3 pi over 6. Another 3 pi would be 6. Another 3 would be 9 pi over 6. And then another 3 would give us that 12 pi over 6. So where does 7 pi over 6 land between, right? What two quadrants, or what quadrant would that land in? And that would be 7 pi would be somewhere between 6 and 9. So that would put us into quadrant 3, right? Somewhere between 6 and 9. So our reference angle is that shortest rotation to the x-axis. And so again, we always want to go to the x-axis. So how far apart is 6 pi from 7 pi? And that would be 1 pi over 6. So then now if I want to figure out that ratio, I want to, for the sine, cosine, and tangent, I always want to make sure that I'm drawing in that triangle, right? So I want to draw in that triangle. And so I know my reference angle is pi over 6, which is equal to 30 degrees. How come I know that's 30 degrees? Because remember, pi is equal to 180. And how many times does 6 go into 180? It goes in 30 degrees. So this would be 30 degrees. So I did a terrible job of making that to scale, but that's okay. So across from the 30 is always going to be 1/2. So across from the 30 is going to be 1/2. And so then adjacent to it is √3/2. And then that radius or hypotenuse is always going to equal 1. So once we label the sides, right? So we're going to label our sides according to our special rights that we know up here, right? So we need to know these. Across from the 30 is 1/2. The second thing we want to do is put our direction on. So this is a step a lot of students forget to do, but we want to make sure we always remember. Direction meaning positive or negative from the origin. So from here, so from the origin, I'm going to head left. So when I head left, that means I'm going in a negative direction. And then I'm going to head down. So when I head down, also a negative direction. And then the hypotenuse is never going to be negative. And so then once we go from there, we're just going to do SOHCAHTOA to find sine, right? So the sine ratio, remember, is the opposite side over the hypotenuse. So opposite here, so from the central angle, so from 30 degrees. So the opposite side is -1/2. And then the hypotenuse is 1, and we don't need to put over 1 because that still will just be the same as -1/2. I'm going to clear off some of this clutter there. Okay, so then let's go ahead and figure out the other two sides, or other two trig functions. So the cosine ratio, remember, is adjacent over hypotenuse. So from 30 degrees, the -√3/2 is adjacent to it. And then over hypotenuse, which is just equal to 1. So again, I don't need to divide by 1 because that doesn't change the value. And then for tangent of theta, that's opposite over adjacent. So from 30, the opposite side is -1/2. And then the adjacent side is -√3/2. And I can't leave it as a complex fraction, meaning that fraction over a fraction. So I want to simplify that by multiplying by my common denominator, which is just 2. So -1/2 of 2 would just equal -1. And then over here, √3/2 times 2, the 2's will reduce to give me -√3. And so that would be 1 over the square root of 3. Or if I choose to rationalize, I would multiply the numerator and the denominator by √3. And I could say it's √3/3 as well. Okay? All right, let's take a look at another one. So let's look at question number 2. So the first thing I want to make sure that I do is I want to make sure that I label my quadrantals, right? So we have a negative ratio, so pay attention to that. So that means we're going to start below the x-axis, which is 0, and we're going to head clockwise in a negative direction. So I will match up my denominator. So this is a value of 3. So instead of calling this pi, I'm actually going to call it 3pi/3, but negative. And then half of 3 is 1.5. So then this distance here is halfway. So that would be -1.5 pi/3. And then count by -1.5s to find the value up above. Or you can recognize that, hey, you already have what is -2 pi in between, and it's in between -1.5 pi and -3 pi. So then I know that I would draw that somewhere over here. And that would give me -2 pi/3. And then that would be in quadrant 1, 2, 3. So that's in quadrant 3. Okay, so then from there, I want to draw in my triangle. And I always want to draw to the x-axis, right? Always draw it to the x-axis because our reference angle, remember, always goes to the x-axis. So that shortest distance is going to be in between -2 pi/3 and 3 pi/3. And so they are 1 pi/3 apart. And remember, keep that positive. So what is pi/3 equal to? Like, how many degrees is that? So remember, pi is the same as 180 degrees, right? We need to know that. So when we have pi divided by 3, it would be the same as doing 180 divided by 3, which is 60 degrees. So that means the reference angle in here is 60 degrees. And then from there, I want to go ahead and calculate the lengths of the sides, and I want to use the special right triangle. So I'm always referring back to this here, right? Like what is what? So across from the 60 is the square root of 3 over 2. So across from the 60 is the square root of 3 over 2. And I'll go back and do my directions here in just a minute. And then from there, I know my adjacent side is going to be 1/2, right? So, and that's because it's across from the 30. So let's get our positives and negatives on here. So we're in quadrant 3. And so I'm going to head from the origin left, so that would be negative 1/2, and then down, so negative root 3 over 2. And then from there, we're going to do our trig ratios. So we're going to use like SOHCAHTOA again. So sine is opposite over hypotenuse. So from the 60 degrees, I know that I have, this is my opposite, this is my adjacent, and that is my hypotenuse. So opposite side is negative square root of 3 over 2. And then, of course, the hypotenuse is just 1. And I don't need to show that divide by 1 because it will still be equivalent. And then our cosine is adjacent over hypotenuse. So the adjacent side is negative 1/2, right? So we're looking up here. So adjacent is negative 1/2. And then over the hypotenuse, which is just 1. And again, I don't need to write that part. And then tangent is opposite over adjacent. So the opposite side is negative root 3 over 2. And then over adjacent, which is negative 1/2. And then just like we did on the previous problem, we want to rationalize, or excuse me, simplify that complex fraction. So then I'm going to do that over here because I kind of ran out of room. So I'm going to multiply the numerator and the denominator by 2. And every single time I do that, those 2's are always going to cancel. So then that would leave me with negative root 3 over negative 1. The double negatives cancel. And then, of course, dividing by 1 doesn't change a value. So then this tangent ratio would be just the square root of 3. And then, of course, we could put the 1 if we want to, but we certainly don't need to do that. Okay, so let's take a look at example 3. So pi over 3. So this is a positive direction, so this would be 0. And then this would normally be 1 pi, but we want to make sure we match that denominator, so that would put that at 3 pi over 3. Half of 3 pi over 3 is 1.5 pi over 3. And then I can see that I can stop here because I'm trying to get to 1 pi over 3, right? So that would be a 1 pi. And that's somewhere between the 0 and the 1.5. So that means I'm going to draw this into quadrant 1. And then I want to find my reference angle. So that shortest distance is going to be to the 0. And so how far apart is 0 from pi over 3? And that would be pi over 3. And then in degrees, I would do, again, remember that pi is the same as 180. So instead of pi divided by 3, I'm going to think of it as 180 divided by 3, which is 60 degrees. So then I know that this angle measure is 60 degrees. So I want to go ahead and draw in my triangle. So I'm going to drop a leg to the x-axis, and I want to label those sides. So it's really important for us to know those triangles, right? So across from the 60 is always the square root of 3 over 2. Hypotenuse is always 1. And so then across from the 30, or adjacent to the 60, is 1/2. And then let's go ahead and label. So then this side is opposite, this one is adjacent, and then that one is hypotenuse. And then as soon as I get to that, I'm just going to do my SOHCAHTOA ratios. So I know sine is opposite over hypotenuse. So the opposite is root 3 over 2. And then dividing by 1 is not going to change that value. Cosine is adjacent over hypotenuse. The adjacent is 1/2. The hypotenuse is 1, and then dividing by 1 won't change the value. All right, and then last one, tangent is opposite over adjacent. So the opposite is root 3 over 2. And then adjacent is 1/2. So to clear those fractions, I'm going to multiply the numerator and the denominator by 2. So the 2's will reduce here and here as well, leaving me with a ratio of root 3 over 1, or just root 3. So one thing I didn't say out loud, but my brain did think it, I just forgot to say this out loud, is for my directions, I'm going to the right. So that would be a positive direction. And then I'm headed upwards, also a positive direction. And so sine, cosine, and tangent would be positive for all three of those. Okay, so let's go ahead and take a look at the last one on this page here. So we have 7 pi over 4, and it's positive. So I'm going to start on the x-axis. That will be 0. And then over on the negative x, that's normally pi, but we want to match up that denominator. So we'll put that as 4 over 4. And then our upper quadrantal, so half of 4 pi is 2 pi. So that would be 2 pi over 4. And then I want to go ahead and count by 2's now that I have that first one. So there's 2 pi over 4. And then another 2 pi puts me at 4 pi. Another 2 pi puts me at 6 pi. And then a final 2 pi would put me at 8 pi over 4. So then once I get to there, I'm trying to figure out what is 7 pi in between. And it's in between 6 and 8. So that will put me somewhere in here. So that would be in quadrant 4. And so I want to draw my triangle always to the x-axis in order for me to find reference angle, always to the x-axis. So I want to figure out how far apart is 7 pi over 4 from 8 pi over 4, because that's its shortest distance. And 7 pi is only 1 pi over 4 away. And then in terms of degrees, so remember pi is the same as 180 degrees. So 4 goes into 180 45 times. So this will be 45 degrees. So I have a hypotenuse of 1. And I know opposite and adjacent will be the same because it's isosceles. So this would be 1 over root 2 or root 2 over 2, right? And so I'm going to stick with that rational denominator form of root 2 over 2. But really, you could put either one. Both would be correct, okay? So again, I'm just sticking with the root 2 over 2 with that rational denominator. Okay, let's get our directions on here. So from the origin, I'm going to head right. So that's a positive direction. And then downwards, so that would be a negative direction. And then from the central angle of 45, this side would be opposite, adjacent, that's an A, and hypotenuse. So sine is opposite over hypotenuse, so the opposite side is negative root 2 over 2. And then dividing by the hypotenuse of 1 won't change that value. And then cosine is adjacent over hypotenuse, so that would be positive root 2 over 2. And then dividing by the hypotenuse of 1 won't change the value. And then finally for tangent, so tangent is opposite over adjacent. So the opposite side is negative root 2 over 2, and then the adjacent side is root 2 over 2 as well. So I have like over like, but one of them is negative, so that would just reduce down to 1. So negative 1 over 1, or just negative 1. Okay, so again, this is a lot like what we did in 8.3, right, where we had to find, or 8.2 and 8.3, I guess, where we're finding quadrants, reference angles, and then trying to figure out all of those trig ratios. Okay, so let's take a look at page 2 here. So for page 2, we're going to be looking at quadrantals and doing the same thing. In order for us to do quadrantals, we need to be able to, label the 4 coordinates here, knowing that we have a unit circle. So a unit circle meaning the radius is equal to 1. So the distance from the origin to the edge of the circle is always going to be just 1 unit. So along the x-axis, to get to this ordered pair, I would head to the right 1 and up 0. To get to this ordered pair, I'm going to go left and right 0, right? And then I would go up 1, and that's how I get that value. And then for this ordered pair here, so I'm going to head left 1, so that's why this is negative. And then I'm going to go up and down 0. Okay. And then we had our definitions that we had in terms of x, y, and r, and this is where this will come into play. whenever we're dealing with our quadrantals. So it's really important that we know these definitions. I know we don't use them often, but we still need to know our definitions. So we are supposed to know that the cosine is x over r. And that just comes from kind of your basic triangle here. So if I call that x and y, I'm going to head to the right x, up y, and then this would be my radius. So from my central angle, cosine would be adjacent over hypotenuse, and that's how I get that x over r. But because our radius is equal to 1, we're really just going to make sure that we know cosine is my x value. And then my sine is opposite over hypotenuse, right? So opposite is my y value, and then hypotenuse, of course, is my radius. And then because my radius is equal to 1, I need to know that sine theta is just my y value. And then finally, tangent is opposite over adjacent, so that's where we get the y over x from. And then we've talked about this quite a bit already, so our conversions, we have that pi is equal to 180 degrees. And so if we want to convert anything, we need what we call a unit ratio, right? A unit ratio to where the numerator and the denominator are equal to each other. So this would always reduce down to 1 because I know that pi is the same as 180. And it doesn't matter if I have the degrees in the numerator or in the denominator, I'm still going to get that ratio that reduces down to 1. And so both of these are going to help me with that conversion, okay, when we get to that example. All right, so let's go ahead and take a look at a few problems here. So we'll take a look at number 5. So we're looking to just sketch each angle. And so I'm going to label my quadrantal. So this would be 0. I'm going in a positive direction. That would be pi. And I can stop right now because I can see that I'm trying to graph theta is equal to pi. So that would be just head straight to the left. And I'm going to darken that just so we can see we're on that x-axis there. And that's going from this direction. And so then once I do that, after I sketch a quadrantal, I want to label that ordered pair. So I want to label that ordered pair. So remember, we're working with a unit circle. So that means I'm going to head left 1 and then up 0. That's my x value. That's my y value. And then remember, the radius is always equal to 1. So if I refer back to this, we need to know that sine is the y, cosine is the x. So just like we've always done alphabetical order whenever we write ordered pairs, so we have like the x is before the y, so the cosine c is before the sine s. So alphabetical order. So the sine value is going to be y. So what is y here? It's equal to 0. Cosine is my x value. What is the x value? -1. And then tangent is like slope. I don't know if you remember that from an earlier lesson, but tangent is slope, so y over x. So my y value is 0, my x was -1, and then 0 divided by -1 is equal to 0. Okay, so let's do one more of these. So -3 pi over 2. So we're going to be going negative, so I'm going to put the 0 below the x-axis, and then over to the left would be -1 pi, but get a common denominator of 2. So half of -2 pi over 2 would be just -1 pi over 2. And then I want to count by ones, right? Because that's -1 pi. So -1 pi, add another one, that would put me at 2 pi. Add another one would be 3 pi. And then add another one would be 4 pi. So where is -3 pi over 2? Well, it's going to be straight up, right? So it's going to be here. So this would be my -3 pi over 2. And so once I get to that, I want to label, that quadrantal with the ordered pair. So if I don't have them memorized, that's okay, right? Because you can look up here. But more importantly, just go ahead and kind of process that. So if I want to get to this dot right here, knowing that I'm working with a unit circle, I'm not going left or right any, so that would be an x value of 0, and then I'm going to go up a value of 1. So this is my x, and this is my y. So sine is the value of y, so that would be just 1. So y is equal to 1. Cosine is the value of x, so x is 0. And then tangent is the ratio between y and x, so that would be 1 divided by 0. And we can't divide by 0, so that would be undefined. Or you can abbreviate that as UND. All right, so let's go ahead and do our conversion. So now when we are converting from degrees to radians or vice versa, we are using that same concept that we did at the beginning of the notes here, is that we know that pi is equal to 180 degrees. And so that means that we're either going to have pi over 180 to multiply by, or 180 divided by pi. And you've done some unit conversions in chemistry, so this shouldn't be too new for you. So if we want to convert 240 degrees, we're going to put that over 1 because we know we're going to work with fractions. And so I want to cancel the degrees. So if I want to cancel the degrees, I want to make sure degrees go in the denominator, right? Because I want the units to cancel. And so if I have 180 in the denominator, then pi will have to be in the numerator, okay? And so then I'm just going to go ahead and multiply straight across and then reduce second. So I'm going to do 240 times pi. And then, by the way, the degrees cancel, so let me go ahead and do that. And then 1 times 180 would be 180. And then from there, we would just reduce this fraction. So I know that I can divide by 10, so the zeros will cancel. So I have 24 pi over 18. And what else can I divide by? I know for sure 2. And 6 for sure. So I think I can just divide by 6. So I'm going to divide both the numerator and the denominator by 6. So that would give me 4 pi over 3. And then that doesn't reduce any further, so that would be my answer. Okay, so these are all kind of the same. So let me do, I'll do number 8, and I'll skip 9, and then we'll do 10 as well. Okay, so let's take a look at this one. So we have 11 pi over 12. And we're going to multiply by a fraction. So right here, I know that I want my radian to cancel, my pi to cancel. So I want pi to be in the denominator and then 180 to be in the numerator. So the pi's will reduce. And so I'll be left with 11 times 180 degrees and then divide by 12. And then I can certainly use a calculator for that if I wanted to, or I could try to do this by hand. So unfortunately, I don't have a calculator handy. So I'm going to do a little bit by hand here. So I know I can divide by 4. So I'm going to go ahead and do that. So that would give me 11 times 45. And then 12 divided by 4 is 3. And then I also know 3 goes into 45 15 times. So then I would have 15 times 11. So what is that? 165? Hopefully I did that right. So that would be 165 degrees. Okay, last one here. So negative 315. So I know I'm going to multiply by a fraction, put that over 1. So I want to eliminate the degrees. So I want the degrees to go in the denominator and then the radian measure in the numerator. So the degrees will cancel, and then I'm going to multiply straight across. So that would give me negative 315 pi, and then 1 times 180 is 180. And then I want to divide to reduce this. So I know for sure I can divide by 5. So that would be 63. And 35. Okay, that was a little slow. And then I can divide both by 7 as well. So that would be 9 pi over 5. And then again, feel free to use a calculator to help you with that arithmetic. And that is the end of that one.